Hello everyone, this is a short video that focuses on the one sample t-test. So the one sample t-test is that test that you use if you have a sample and you want to compare that sample's mean to the mean of the population. So that's what we're going to run today. So here I have all my modules ready. I got this data set from Kaggle and I loaded it onto my Google Colab. And here I take a look at the first 5 rows of the data frame and I see the 6 columns. And then I do the info and I see that I have some 1,300 plus rows. There are no missing values. Several of these are numeric and a couple of them are actually categorical. So if we do some very elementary descriptive statistics, we can see what these features or variables look like. And we see we have the earnings or the wages, but because this standard deviation is so large, almost as large as the mean and we see that this max is like 1 order of magnitude greater, there is a significant skew here. So we're going to use the height variable, right? And so this seems like it would qualify for at least a t distribution. So our question is the age of the mean age of the sample, I should say, the mean age of the sample measures different from that of the mean age in the population. So I've taken some liberties and I have said that I think the mean age of the population is 0. And so that's what we're going to use. So we have our null hypothesis. The mean age of the sample is the same as that of the population. And our alternative hypothesis says that the average age of the population is less than that. The average age of the sample, sorry, is less than that of the population. So we're effectively going to be doing a left-tailed test, right? So we're going to be looking to see if the critical value for our sample is in this rejection region or not. So we go ahead and we have set our alpha level at 0.05, and we can use this formula from the stats module and give us the results, right? We simply put in the series that or the values as an array, the age values, and then we use the mean value for the population, and we can actually run that, and we would get our the values for our t-stat and our so t-stat is that, and the p-value is very, very small. So already we can see that this p-value or the probability is somewhere very much in that rejection region, right? And we can make certain claims about the results or about the sample size. This is just another way that you can run this test in using the t statistics. So you get the mean, and then you get the standard deviation, and you get the degree of freedom or the sample size, which you're going to use to get the t-stat value. And we see here that it is some minus 10.99, definitely in the rejection region. So when it was much lower than our T critical, so the T critical is here and our T stat is way out here somewhere. So this definitely, if we were to run our test, we see that we would reject the null hypothesis because the P alpha is less than the alpha, and the T critical is definitely in the rejection area. So we would reject the null hypothesis in this case.